increasing and decreasing functions in the first derivative test. A function is increasing if the y value is increasing along the interval, and it's decreasing if the y value is decreasing along the interval. If you consider the graph y equals x squared from the interval -3 to 3, you can see that the function is increasing from 0 to 3 because the y value is increasing, and decreasing from -3 to 0 because the y values are decreasing. Another important point in calculus is the maximum and minimum. A minimum occurs when the graph goes from decreasing to increasing. The maximum is from increasing to decreasing. This graph has a minimum because it goes from decreasing to increasing along the interval, and it doesn't have a maximum. Hi, I'm back. I will show you an example of the first derivative test on the easy equation we had earlier, just to illustrate how to do it. The first thing you must do is find the derivative of the function, which I have done already. And you need to know something, and that is critical numbers are where the derivative of f of x is equal to 0 or undefined. So the first step is to set the derivative equal to 0. And when you solve for x, you get x equals 0. So that is the critical number. And there's no other critical number because x can't equal anything else when the derivative equals 0. And also, there are no undefined. And then the next thing you do is you take the interval from -infinity to the critical numbers. In this case, we only have 1, so it's 0. And then from 0 to infinity. Then you choose some number c in between -infinity and the critical number, and the critical number and infinity. Choose the easiest numbers for the easiest calculations. I would choose -1 and 1 in this case. And then you plug these back in to the derivative. And then you find the sign of f of c. And for this interval, you get negative. And for this interval, you get positive. And what these signs mean is that since this is negative from -infinity to 0, intuitively you can see that the graph f of x is decreasing. And since f dash of c is positive for 0 to infinity, you can see that the graph f of x is increasing. And the next thing you need to know how to do is how to find the max or min of the graph of f of x. Wherever f dash of x changes from negative to positive, the sign changes, is when there's a minimum on f of x, and positive and negative is a max on f of x. In this case, the sign changes from negative to positive at the point 0. So, how you would write this as an answer is, there is a minimum at x equals 0 at f of x equals 0 as well, because you would plug in back into the original equation to find f of x.
Hi, I'm Thomas, and I'm back. Now, Rahul's example was a pretty easy one. Well, let's take a look at this one. This one would be pretty hard to graph just on your own, right? So what we're going to need to do is we're going to need to use the first derivative test to find the extrema. Now remember, to find the extrema, we need to find where f of x is increasing and decreasing. So, let's start with the first derivative test. First, you find the derivative, and you take the derivative and set it equal to 0. Like so. Then you solve. Okay. So as we can see here, there is an extrema, which means a max or a min, at 2 and -2. Now we don't know whether it's a max or a min yet. They could be both be maxes, could be both mins, we have no idea. That's why we do the first derivative test. Now let's test our intervals. Okay, now we're going to want to find the easiest value to test. Here I would choose -3, 0, and 3. Now, when we plug in -3 to this equation right here, remember, we want the f prime of c sign. We get a positive number. Plug in 0, we get a negative number. Plug in 3, we get Now what this means is that on the interval from negative infinity to negative 2, the graph is increasing, like so. From negative 2 to 2, it is decreasing, and from 2 to infinity, increasing, which means we have a max here at negative 2, and we have a min here at positive 2. Now, how we write this is max at x equals negative 2 at, now we plug in negative 2 to the original equation, which is 11. Then we plug the min in at x equals 2, and plug in 2 back up here, we get at negative 21.
Go.
First derivative test has many applications in real life. Let's take, for example, a spaceship moving on a varying speed over position. The position is given by this function right here, 5x to the 5th plus x to the 3rd plus 4x squared. And what we're going to want to do is we're going to want to find where speed is at a max on this interval right here.
Okay, so the first step is to find the derivative just like always. And then you find the zeros, and we already did that ahead of time, at the same time, 0 and this number right here. And you would do the same thing, except you would go from, instead of going from negative infinity to infinity, since this is bounded, you would use these endpoints right here. The lowest endpoint, negative 0.85 to 0. Then from, no, not 0. Negative 0.62566646. Then from this number to 0. Then from 0 to 0.25. And the next thing we would do is choose the values. Try to pick some easy values here. So we could do negative 0.75, negative 0.5, and there's not really an easy one here, but you could do 0.1. And then you would plug it into the equation and find the sign. Okay, so I found the signs for all the c values of the derivative. You get positive, negative, and positive. And as we've explained before, the maximum is when it goes from a positive to a negative. So you can see there's a maximum at this value right here. And a minimum is when it goes from negative to positive. So there's a minimum at 0. So the spaceship speed is a maximum at x equals negative 0.62566646, at y equals 0.84. Just calculate that by putting it back in.